Good morning, guys. So today in class, we are going to start with this packet right here. This is your function packet. You will find it in the folder that was in your bag with your STEM challenge materials. So why don't you pause the video, go find your packet. It looks like this. I believe it's like the only packet in that folder. And play the video when you're ready. Okay, so what we're going to do today is we are going to talk about functions, and it's a relationship. Functions are relationships amongst numbers, terms. It could be a relationship amongst data that isn't numbers. It could be the number, or it could be the student name and their birthday. So they could still have an input output of birthday versus birthday month versus student name. Okay. So what we're going to do today is we're going to talk about what makes something a function. So we can see here on the cover, we see a function machine. It's a picture of a typical function machine. You input something and you get an output. Okay. Sometimes that output is called f or f of x. That's a very fancy way of seeing it. We won't really see it like that in 8th grade. We see it more like that in 9th grade. Let's take a look at page 1. So we're going to be focused on notes 58, which is page 1 of this packet. We can see in this top right corner, this is notes 58. This is kind of a more typical way of looking at 8th grade. If it were a typical year, we wouldn't be using a workbook necessarily. We'd be using our packets. All right, so determine a function. Your job at the end of today is I can state whether or not a relationship is a function. Okay, so make sure you, by the end of the lesson, you kind of understand function, not a function. A relation is a set of ordered pairs. A function is a relation in which each input or x value corresponds to exactly one output value or y value. A function or other relation can be represented as a set of ordered pairs in a table, as an equation, or by a graph. So then we added this, also a verbal representation. So we can represent functions in a lot of ways. This is a lot of words. So what we're going to do right now is we're going to make the classic answer. And you're going to use this classic answer in 9th grade too, okay? So if it's a function, you're going to write this. Every input has only one output. Every input has only one output. So if you input 2 into your function machine, you can't get 3 out of it and 4 out of it and 5 out of it. Okay, it doesn't work like that. If you input 2 in order to be a function, you can only get 3. Okay, you can only get one value out. You can't get 3 different values that are outputs of 2. So let's take a look at the tables first. So again, we're going to look at all these 3 ways: ordered pairs, table, equation, graphs, and verbal representations, and how they look as functions. Okay, so let's check out the tables. So again, we know that our inputs are always our x's. So let's write that up here. Input, output. Table 2, we can write the same thing. Input above x, output above y. So let's take a look at that input on table 1. We have an input of -2, -1, 0, and 1. Okay? Well, when I input -2, I get out -4. -1, input, get out -1. Input 0, get out a 2. Input a 1, get out a 5. Does every input have only one output? Yeah. Let's check out the inputs for table 2. I input 4, I get out -2. I input 2, I get out -1. I input 1, I get out a 0. I input 2, I get out a 1. Does every input, every value, have only one output? No. So right here, the input of 2 happened twice, and their outputs are different. Therefore, this is not a function. Not a function. The input of 2 has 2 different outputs. Now you might be like, wow, this is a lot of writing. Yeah, this unit is a lot of writing. So it's like explanation answers. So make sure you're writing them with me so you are getting practice with, what it sounds like, what it feels like to write the answers. So this is not a function because the input of 2 has 2 different outputs. And then under table 1, we'll write a function. And then let's put an arrow for our reason why, which is the reason we're going to use every time that it is a function. Every input has only one output. Okay, let's go check out the next part. So in a function, the set of input values is called the domain, and the set of output values is called the range. Braces, Mrs. Brown calls them fancy brackets, are often used when listing the domain and range. So let's take a look at example 2. Identify the domain and range for the function shown below. So our domain is all of the x values. So we're going to write domain, fancy bracket, and we're just going to list all the x values, -2, 1, 2, 3. And our range is all of the y values. So we're going to state the word range, fancy bracket, and we will write all of the outputs that we see. However, you don't want to ever repeat an output. And as I look across the y's, I see a 1, 2 4s, and a 9. So really our range will be 1, 4, and 9. We don't repeat that second 4. Now let's talk quickly about whether or not this table represents a function. So for the input of -2, I have an output of 4. For the input of 1, I have an output of 1. For the input of 2, I have an output of 4. And for the input of 3, I have an output of 9. Does every input have only one output? Yes. It's okay that they have the same output. It's just that no input can have 2 outputs. No input can repeat and have something different happening. So this, yes, this is a function. When you're ready, we're going to turn to page 2. Now we're going to investigate ordered pairs, okay? So let's take a look at the ordered pairs. Remember that the x's come first before y's. So in this first ordered pair, 2, 6, we have an x and then a y. 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 Okay? So if we were to look at just the x values, why don't I grab a highlighter really quick? Just the x values. Does any x value repeat? Yes. I saw 3 happen twice. And does 3 have 2 different outputs? 3 is inputting or outputting 9, and then 3 is outputting 12. So is this a function? No. So this is not a function. The input of 3 has 2 different outputs. And they could show you that it has 7 different outputs. You could just say it has different outputs. Or you could say it doesn't have only one output. Okay, now they're mentioning something up here about a mapping diagram. So I'm going to show you what that looks like real quick. So you're going to have x's and you're going to have y's, okay? And we can put them in a box. We can put them in a circle. Let me just jump ahead and show you like what it might look like. Here's a circle mapping diagram right here, okay? So it's just pointing to the inputs and where their outputs are landing, okay? So let's just list our inputs, our x's. So we have 2, we have 3, we have 4, and we have 5. Remember, we don't repeat that 3. Essentially, we just listed the domain. So now let's list our range. So we have a 6, a 9, a 10, a 12, and a 15. And again, they like you to list them in order, keeping everything consistent. Remember that we are mathematicians, so we like order about things. So now we make lines from the input to the output that it goes with. So 2 goes with 6, 3 goes with 9, 3 also goes with 12, 4 goes with 15, and 5 goes with 10. So now checking that out, we can see that this input of 3 has 2 lines coming out of it. Do we want 2 lines coming out of an input? No, because that means it has 2 different outputs. So therefore, again, this same statement rings true. It is not a function. The input of 3 has 2 different outputs. This is just more of a visual for us to see it instead of just looking at those coordinate points. You could make a mapping diagram from a table, okay? But we have to be able to read all of these types, so that's why we're going over them. Okay, the last way we're going to talk about today is the graph of a function is basically there's something really, really cool called the vertical line test, okay? And basically if the x value has 2 outputs, 2 y values, then it will not pass the vertical line test and it is not a function. So what they're doing here, I'm going to continue to use my blue highlighter so you'll see it better. But what they're doing here is they're saying as we draw these vertical lines down, each time it only passes through our function once. Therefore, it passes the vertical line test. Now, over here, here's our function. We can see it graphed, okay? As I draw a vertical line down, it just hit here and it hit here. So in that one vertical line, it has hit my function twice. So therefore, it is not a function, okay? So let's take a look at example 4. Which graph represents a function? When we look at these pictures are getting very old as we photocopy them over and over again. So this one is essentially a sine graph. This one looks like this. It comes across, it goes down a little notch, and then it comes over. So as we look to make vertical lines through them, just gonna get a different color again. Graph 1, you're only passing through once each time. Graph 2, you're passing through once except for right here at x equals 1. Right there at that little notch, we pass through more than one. So this is not a function. So we are going to circle graph 1. It says which graph represents a function. And we can say graph 1, geez, Brown, is a function because it passes, this will be your reasoning, it passes the vertical line test. It passes the vertical line test. So then we can say about this one, it fails the vertical line test. Okay, your job tonight for homework, guys, is to try page 4, number 5, and 6 only. So try those 2 problems on page 4. Interestingly enough, you can only use this reasoning on graphs, remember, okay? But you could say that every input only has one output about this graph, right? And then you can say about this graph that at x equals 1, there's too many outputs, okay? All right, so I will see you guys later and have a great night, and we'll discuss more tomorrow. Bye.